Hey, welcome back. Today we're going to take a look at how to find the distance between two parallel planes. Speaking of parallel, very funny joke. Let's say you find yourself at a math conference and you're pretty bored. Just say this joke. Here it goes. Ready? Two parallel lines met on a plane. Get it? They're parallel. They don't meet. Very funny joke. Anyway, so how we find the distance between two planes that are parallel is the same way that we find the distance between a point and a plane. So in order to do this, what we're going to do is we're going to set one plane as kind of like a constant, and the other plane is we're just going to pick a point on it. So I have two planes here, and their equations are 2x minus 5y plus z equals 4. We'll put that on the bottom. 2x minus 5y plus z equals 4. And this plane could be 4x minus 10y plus 2z equals 9. And I want to find the distance between them. Now it would be really super easy if I knew that one point on one is directly above one point on the other. But we don't know that, so what we do is we're going to pick one of these planes and just pick a point on it. So I'll pick a point on the top plane and I'll call it point P. And I can get P by just picking values for x and y and then solving for z, or so on and so forth. For example, if I let x be 0, I let y be 0, I know z will be the point 9 over 2. So P will have the coordinate 0, 0, 9 halves, like that. Next, what I want to do is I want to find my vector normal from the bottom plane. So remember, we have an equation, right? Our distance, right? We talked about this. The distance between a point and a plane is the projection is given by this form right here. PQ dotted with the norm over the magnitude of n. So what we have to do is we have to find some vector PQ. And this is a projection, which we'll talk about in just a few moments. So so I pick a point down here. We'll call it Q. Well, I'll pick another point over here. We'll call it Q. And there we go. And what I'm going to do, I'm going to draw my norm. From this point, I'll draw my norm up to P. Now, it is normal, so it is going to be perpendicular. We know that. And if I draw the vector QP, what we are looking for is this projection right there. And that's what we're out to find right here. So to do that, that's what we have here. PQ dotted with n. This is going to be n divided by the magnitude of n. And so pretty easy to get. So the first thing we're going to need to do is find, of course, point Q down here. So Q is on my bottom vector, so I can get Q again by picking values for x and y. And I can say, well, x is going to be 0, y would be 0, and z would, of course, be 4. Go simple on this one. So if I'm looking for the distance right away, I can get PQ. Now, PQ would just be, let's see here. Now, I'm going the opposite direction, so I shouldn't call it PQ, so let's call it QP instead, just to make sure we get our directions kind of straightened out. The direction doesn't matter because we are going to take the magnitude of it anyway. It's the absolute value. So if I get QP, that's going to be 0. 0 minus 0, 0. And then we get this 9 halves minus 4 halves. So we just go 9 halves, minus 4, not 4 halves. And if we subtract that, we're going to get 0, 0, 1 half. And there's vector QP. To get n, now n is just the normal vector to our bottom plane. And recall from an earlier video, to get the normal vector, that's just our A, B, C coordinates from our plane, the equation of our plane. So A is going to be 2, B is negative 5, C is 1. And now we can just get their distance by using our formula. Now in an earlier video, in an earlier video, let's see if I can get that focus there. There we go. In an earlier video, we showed how to come up with this equation. Please take a look at that if you need to. So we're just going to plug it into our formula now, get our distance. It's going to equal the magnitude of our dot product of P, Q, and N. So it's going to be 0, 0, 1/2 dotted with 2, -5, 1 divided by the magnitude of N, which would be the square root of 4 plus 25 plus 1. And if we simplify this one, we get, what's this, 1/2 basically, divided by the square root of 30. So it would be 1/2 root 30, and that's how far apart those two planes would be. Anyway, like I said, if you need to, go back and look at my past videos to find out how we get that distance between a point and a plane. Remember, this is the distance between a point and a plane, and that's what we used here. We just set one plane, use one of the planes to get a point on it, and then we just can use our old distance formula from earlier. Hope you enjoyed the video, and I'll see you later. Bye-bye.